Tonight I'm going to teach you, or tell you yet another way that you can use matrices to solve linear systems. And what I'm going to teach you tonight is how to find the inverse, of a matrix. As you're listening to this, you may hear this peaceful water type noise in the background. That's my dishwasher. Okay, so let's say I have a matrix A. Well, if I want to find the inverse, I just want to let you know that A to the negative 1 denotes the inverse of matrix A. So how do I find the inverse matrix? So let's say I have a matrix, a square matrix, a 2 by 2, and it's A, B, C, D. Well, to find the inverse of this matrix, I find the determinant of A, and I multiply it by kind of a rewritten matrix A, meaning I swap these two, and I make C and B negative. So my rewritten matrix is D, A, those two positions are swapped, negative C, negative B. And let's remember that A, that means the determinant of A, equals AD minus BC. And that cannot equal 0. If it equals 0, you are done. Okay, this is a very useful tool for finding the solution to a linear system. But seriously, what is an inverse? Basically, an inverse matrix is the matrix that if I multiply it by, if I have matrix A, and I multiply it by its inverse, I get what's called the identity matrix. And the identity matrix has ones down the main diagonal and zeros everywhere else. And if I multiply, now this is one situation where if I multiply A times its inverse, or its inverse times A, I still get the identity matrix. So let's see if that works out, okay? Let's take an example, and we will do, let's say I have a matrix A, and we'll go back to our A, B, C, D. A, B, C, D. So, no, we are not going to do that. Nope, changed my mind. Let's say that I have a matrix A, 3, 8, 2, and 5, and I go through the process that I just showed you, and it turns out my inverse matrix is A is negative 5, 8, 2, negative 3. Okay, well, let's just multiply these two together and see if I really do get the identity matrix. So I have 3, 8, 2, 5 times negative 5, 8, 2, negative 3. Okay, so here, this is good practicing our multiplying matrices. So our first element, or the element in the first row, first column, will be 3 times 5 plus 8 times 2. So 3 times negative 5 is negative 15 plus 16. That gives us 1. And over here we have this first row, second column. So 3 times 8 is 24 plus 8 times negative 3 is 0. So far, so good. Now let's do this one down here. 2 times negative 5 is negative 10 plus 5 times 2 is 0. And then our last element is 2 times 8, which is 16. 16 plus negative 15 is 1. So apparently it works. Okay, let's do an example of finding the inverse of a matrix. Let's go back to our matrix A that I just used, and I said it was 3, 8, 2, 5. Now, to find my inverse, I find the determinant, which is 3 times 5 minus 8 times 2. So 1 over 3 times 5 minus 8 times 2. And I am going to multiply that by, I have to swap these two elements, 5, 3, and multiply these two by a negative 1, or make them the opposite. And I say negative 1, and I write negative 1. So it's negative 2, negative 8. Okay, well, let's do this. 3 times 5 is 15. 15 minus 16 is negative 1. 1 divided by negative 1 is negative 1. And I am going to multiply that by this matrix. And so my inverse is, I keep forgetting that little notation, negative 5, 8, 2, negative 3. So there's an example on how to find the inverse of a matrix. So how does this help us? Well, essentially, if I have a linear system, let me see here. Let me come up with a good linear system for you. Okay, let's find the solution to this linear system. First of all, what I want to do is I want to set up my matrix A, which is my coefficient matrix, and that would be the coefficients in front of the variables. So I have 2, negative 3, 1, negative 4. And then I have my answer matrix. I'm going to call my answer matrix B. And that is 19, negative 7. 19, negative 7. Okay, let's go ahead and find the inverse of matrix A. So, I need to find the determinant, which is 2 times negative 4. So let's see here. If I do determinant of A equals 2 times negative 4 minus 1 times negative 3, gives me negative 8 plus 3, or negative 5. Alright, sadly, I made a mistake. That should be plus 4. So that should be plus 4. So this should be plus 4. So that should be 8 plus 3. And this answer will be, scratch that out. That answer is 11. I apologize for that. So that means we scratch that right out. And my inverse matrix is 1 over 11 times, now let's swap these two positions, 4, 2, and make these two negative. So the opposite of negative 3 is positive 3, and I have negative 1. Well, this looks kind of yucky. Alright, if I multiply this out, I get 4 over 11, 3 over 11, negative 1 over 11, and 2 over 11. Alright, that looks super. Now, how do I find, oh, there's the cat. How do I find my answer? Well, at this point, I take matrix B, and I multiply it by the inverse of matrix A. And that'll give me my solution for x and y. So let's set that up. I have the inverse of a, which is 4 over 11, 3 over 11, negative 1 over 11, and 2 over 11, times (19 minus 7). Wow, this looks great. So let's do this. All right, first row, first column. So 4 times 19 is 76 over 11 minus 21 over 11. And then my element down here will be this row, this column. So negative 19 over 11 plus negative 14 over 11. 76 minus 21 equals 55 over 11, and negative 19 and negative 14 gives me negative 33 over 11. So that means x is 5 and y is negative 3. Now, can you find the inverse of larger square matrices? Well, yes you can, but I'm not going to make you do it because it is a long process, and if I ask you to solve a linear system with 3 or more variables, well, I would let you use a graphing calculator. However, for practice, I would like you to find the inverse of these 3 matrices. So 6, 1, 2, 4. That's your first one. Your second one is negative 1, 5, negative 4, 8. And your last one is, let me see, maybe I can find a nice linear system for you to solve. Here, try and solve this linear system. Negative 2x plus 3y equals 11, and 5x plus y equals 19. Now remember, you want to set up matrix A, which is your coefficient matrix. That'll be a 2 by 2. And matrix B, which is your answer matrix, will be a 2 by 1. Good luck, and I will see you in class.